Hey everyone, it's Justin again. You've already learned how to graph quadratics in one form, and we're almost ready to learn a second form. But before we can start on that second form, you'll need to know how to use square roots to solve equations, because it'll have a major role in the second quadratic form. At the end of this lesson, you will be able to solve equations by using square roots. First, we'll quickly review square roots, then practice together with 3 examples of how to use square roots to solve equations, or I give you one example to do on your own. First, recall what a square root is. The square root of a value is the number that you could square to make it. If 4 times 4 makes 16, then a square root of 16 is 4. Squaring and square roots are inverse operations that cancel each other out. So now that that's out of the way, how would we solve this equation? X squared equals 25. To cancel out the squared, we perform its inverse operation, square root. And whatever we do to one side has to happen to the other side. The square and square root cancel out. All we need to do is simplify the square root 25. You know what the square root of 25 is? It's 5. Oh, right. I always forget about that. So that symbol is called a plus minus. And that means that there are 2 values here, the positive version and the negative version. To understand why, let's rewind a second. We said that since 4 squared is 16, the square root of 16 is 4. But that's only half right. There's another number that squares to make 16, negative 4 squared. That's also 16. Multiplying negative times negative makes a positive, just like multiplying 2 positives. So then 16 doesn't have 1 square root, it has 2, 4 or negative 4. So that's why we got that plus minus symbol. Any positive number could be the result of squaring a positive or a negative. Most of the time we have no way of knowing which is correct, so we just have to accept both answers as valid. We can even use this new symbol in our answer. Instead of saying the answer is positive 5 or negative 5, we could just combine them and say positive or negative 5. So then, positive values always have 2 square roots. What about negative values? What could we square to get negative 9? Well, negative 3 times itself would still be positive 9. Positive 3 times itself also just makes positive 9. We can't multiply positive 3 and negative 3 because then we're not squaring either number. They're different numbers. Is there even an answer? To put it simply, no. There is no real number that can be squared to make negative 9 or any other negative number. We call this undefined. The square root of any negative number will be undefined. This video isn't just about square roots though, it's about using them to solve equations. Let's try this example. X minus 2 squared equals 100. It would be great to get that minus 2 moved over, but it's trapped inside the parentheses, which are there because of the exponent. So in order to solve this, we'll have to deal with the square first. Cancel it out, we throw a square root around it. Do the same to the other side. Square root cancels out the square, so now we've got an easy x minus 2 on the left side. Right, the square root of 100 is 10. Except not necessarily. It could be positive or negative 10. We need to add 2 to both sides in order to finish solving the equation, but how can we do that if we don't know whether the right side is 10 or negative 10? If it's 10 and we add 2, our answer becomes 12. But if it's negative 10 and we add 2, we get negative 8 instead. So which one is it? Well, it's easy. It's both. Or either. It could be one or the other, and without any context here for what these numbers represent, all we can say is that both answers satisfy the equation. If you want proof, just plug the answers back in. For negative 8, negative 8 minus 2 is negative 10. Squared is 100. So negative 8 works. What about 12? Subtract 2 and we get 10. That squared is 100. So both negative 8 and 12 are correct solutions here. How about an even harder one? You might be tempted here to just start with a big square root here. After all, that's how to cancel a square, right? But here's the problem. This 25 is on the outside of the square, so it blocks the square root and square from affecting each other. We'll have to move the 25 first. So we add 25 to both sides of the equation, and now there is nothing blocking the square and the square root from canceling out. On the right side, remember the square root of a positive can be positive or negative, so x plus 3 is either equal to negative 5 or 5. If it's negative 5, then we subtract 3 and get that x is negative 8. If it's positive 5, then we subtract 3 and get that x is 2. Check, plug them into the original equation. If x is negative 8, then negative 8 plus 3 is negative 5. Negative 5 squared is 25, and 25 minus 25 is 0. Negative 8 works. We try 2 instead. 2 plus 3 is 5. Squared is 25 minus 25 is 0. So 2 works as well. Did you happen to notice what's special about these two x values? When the input is negative 8 or 2, the output, 0. Why does that sound familiar? Because that's the exact definition of a function's roots. When we set up our equation to solve, we had a quadratic function on one side, equal to 0 on the right side. When you solve equations with this setup, you're solving for the roots of the quadratic function. Time to test what you just learned. What are the roots of this function? Don't forget, finding the roots means solving for when the function is equal to 0. Pause the video while you work it out, and then I'll give you the answer. If we want to find the roots, we have to remember what that means. What values of x cause the function to output 0? To solve this, we add 121 to both sides, take the square root of both sides, which will cancel out the square, and split the equation in two. Either x minus 1 equals negative 11, or it equals positive 11, which means x has to be either negative 10 or 12. Don't take my word for it, though. Check these answers yourself. Throughout this video, you've actually been looking at the next form of quadratic functions that you'll be learning about. In the next video, you'll learn how this new form works and how to use it to graph quadratics. See you then!